Download this code from codegive.com, link in the description below. Fixing deflate quick when resuming due to filled output buffer 14 errors. This error, often encountered when working with the zlib library, or libraries using zlib under the hood, for data compression and decompression, specifically while using the deflate function with the z_sync_flush or z_full_flush strategy, indicates that the output buffer you provided to the deflate function is not large enough to accommodate the compressed data that zlib needs to write. This typically happens when you're using the quick deflate path, which is optimized for speed but may require more space in the output buffer for certain data patterns. Here's a detailed breakdown of the problem, its causes, solutions, and a code example. Understanding the problem. Deflate is the core compression algorithm used by zlib. It's a lossless compression technique combining LZ77, finding repeating sequences, and Huffman coding, statistical coding of symbols. Zlib is a popular and widely used open-source compression library. It provides a C API for performing deflate compression and decompression. Many other libraries, like Zip, Python's zlib module, etc., are built on top of zlib. Deflate function. The deflate function is the workhorse of zlib's compression process. It takes input data, compresses it, and places the compressed output in a provided output buffer. Crucially, you must manage the size of the input and output buffers yourself. Z_sync_flush and z_full_flush*. These strategies control how the deflate function flushes the output buffer. Z_sync_flush flushes the output buffer, allowing the decompressor to catch up. Adds markers to allow the decompressor to partially decode the stream. It does not empty the internal state of the deflate algorithm entirely. Z_full_flush, more aggressive than z_sync_flush. Completely resets the internal state of the deflate algorithm. This creates a point where the decompression can start anew, even if the previous data was corrupted. It's more expensive than z_sync_flush in terms of compression ratio and processing time. Quick deflate path. Zlib has several different optimization paths for the deflate algorithm. The quick deflate path is optimized for speed but sometimes produces a slightly larger compressed output than other paths, especially when flushing. Filled output buffer 14 *. This specific message isn't always a direct error code from zlib, but it's a descriptive message often generated by code using zlib. The 14 might be a specific code within the application or an indication of a particular stage in the compression process where the output buffer became full. The underlying cause is that the output buffer you provided was too small to hold all the compressed data produced during a deflate call, particularly when using z_sync_flush or z_full_flush. Resuming. The term resuming suggests that you're not compressing a single block of data in one go. You're likely calling deflate multiple times with different input blocks, and this error is happening during one of the later calls. This is a very common scenario when dealing with streaming data, example compressing data coming from a network connection or a large file. Causes of the error. 1. Insufficient output buffer size. This is the most common culprit. The output buffer you're providing to deflate is simply not large enough to accommodate the compressed data. The size needed depends on the input data, the compression level, and the flush strategy. 2. Incorrect buffer management. You might be making mistakes in how you update the avail_out and next_out members of the z_stream struct between calls to deflate. If you're not correctly tracking how much of the output buffer has been used, you might think you have more space available than you actually do. 3. Aggressive flushing asterisk using z_full_flush too frequently can exacerbate the problem. z_full_flush resets the internal state of the deflate algorithm, potentially requiring more output space than z_sync_flush. Only use z_full_flush if you genuinely need a completely independent compression stream at that point. 4. High compression level asterisk higher compression levels, example z_best_compression, can sometimes lead to slightly larger output sizes, especially with certain types of input data. 5. Incorrect initialization asterisk it's possible, though less likely, that you didn't correctly initialize the z_stream structure before calling deflate init to. Make sure all fields are set to appropriate initial values. Solutions. 1. Increase output buffer size asterisk this is the primary solution. The larger the output buffer, the less likely you are to encounter this error. You can increase the size of the buffer to the recommended size, based on the input size. There are some recommendations, see below. 2. Correct buffer management asterisk carefully review your code that manages the output buffer. Make sure you're correctly updating avail_out, the number of bytes available in the output buffer, and next_out, a pointer to the next available byte in the output buffer, after each call to deflate. A common mistake is to forget to increment next_out and decrement avail_out based on the number of bytes written by deflate. 3. Reduce flushing frequency, if applicable. If you're using z_full_flush very frequently, consider whether you can reduce the frequency and use z_sync_flush instead. Only use z_full_flush when you truly need a complete reset of the deflate state. 4. Reduce compression level, if applicable. If you're using a very high compression level, try reducing it, example to z_default_compression or even z_best_speed. This might reduce the compressed output size and avoid buffer overflow. 5. Check deflate, return code asterisk always check the return code of the deflate function. It will tell you whether the function succeeded, encountered an error, or needs more input or output space. Important return codes include *z_ok, the function completed successfully. *z_stream_end, the end of the compressed stream has been reached. *z_buff_error, the provided buffer, either input or output, was not large enough to proceed. This is the error you're likely seeing, although it's often masked by the higher level application message. *z_stream_error, the stream structure was not properly initialized, or the function was used in an inconsistent way. *z_mem_error, there was not enough memory to allocate. 6. Dynamic buffer allocation *. A more advanced, and potentially safer, approach is to start with a reasonable output buffer size and then dynamically reallocate the buffer with a larger size if deflate returns z_buff_error. This avoids allocating a very large buffer upfront if it's not needed. Be careful to handle the allocation failures properly. 7. Verify initial buffer size *. Make sure you're providing enough initial output buffer. A common guideline is to provide an initial output buffer that is at least as large as the input buffer, and often larger, especially when flushing. Code example, see. This example demonstrates a basic streaming deflate compression implementation with proper error handling and a slightly larger output buffer than the input. It also includes a simple dynamic buffer resizing approach. Key improvements in this example. Clear error handling checks the return code of deflate init, and deflate, and prints meaningful error messages. Output buffer management carefully updates avail_out and next_out after each call to deflate. Asterisk dynamic buffer resizing asterisk the code includes a basic dynamic buffer reallocation strategy. If avail_out becomes 0, meaning the output buffer is full, the buffer is reallocated with twice the capacity. This handles the case where the initial output buffer size is insufficient. You might want to use a different reallocation strategy depending on your specific requirements. *z_finish uses z_finish when strm avail_in is 0, indicating that all input data has been processed. This ensures that the compression stream is properly terminated. Do not use z_sync_flush or z_full_flush unless you have a specific need for them. In most cases, z_finish at the end of the data is sufficient. *constants uses chunk and initial_output_ multiplier to define the buffer sizes, making the code more readable and easier to modify. How to compile and run. 1. Save the code as a .c file, example compress.c. 2. Compile use a C compiler, like GCC, to compile the code, linking with the zlib library. The exact command will depend on your system. *lz tells the linker to include the zlib library. Make sure zlib is installed on your system. On Debian/Ubuntu, sudo apt-get install zlib1gdev. On Mac OS, using homebrew brew install zlib. 3. Run *, execute the compiled program. Important considerations *. Deflate init 2, for advanced control *. Instead of deflate init, you can use deflate init 2, for more fine-grained control over the compression parameters, including the window bits, which affect memory usage and compression ratio. Read the zlib documentation for details. Decompression you'll need a corresponding decompression routine to decompress the data produced by this code. Use inflate init, inflate, and inflate end, in a similar way. Error handling the example includes basic error handling, but you should add more robust error handling to your production code, including checking for memory allocation failures and handling other potential errors returned by zlib. Real-world scenarios in a real-world scenario, example network communication, file compression, you'd likely be reading data in chunks from a source, like a socket or a file, and writing the compressed data to a destination, like another socket or a file. The code above provides a basic framework for that, you'd need to adapt it to your specific application. Memory management always free the allocated memory, using free, when you're finished with it to avoid memory leaks. Pay close attention to the memory allocated for the input buffer, the output buffer, and the z_stream structure. Flush strategies be very deliberate in your use of z_sync_flush and z_full_flush. Incorrect or excessive flushing can severely degrade compression performance. Debugging use a debugger, like GDB, to step through the code and inspect the values of variables, especially avail_in, next_in, avail_out, next_out, and the return codes of deflate, if you're encountering problems. By carefully managing the output buffer size and paying attention to the return codes of the deflate function, you can effectively resolve the deflate quick when resuming due to filled output buffer 14 error and ensure the reliable compression of your data. Remember to adapt the example code to your specific application's needs and add robust error handling for production use.